this video, we're going to solve the 2008 AP Calculus ABA pre-response question, Form A, question number 1. Let R be the region bounded by the graphs of y equals sine pi x and y equals x to the third minus 4x as shown in the figure above. Find the region of R. So now we have to distinguish which one's the top function. So what I did is I plugged in 1 to figure out which one was which. I got sine of pi, which is 0. This has to be the top function, y equals sine pi x. And when I plugged in 1, just to be safe, I got negative 3. So this has to be the bottom function. So if we want to find the area, we need to find the boundaries where they intersect, which it happens to be 0 and 2, but I always recommend that you actually solve and you use your TI-89, because sometimes it looks like it's something, but it's really not. So you're going to do sine pi x minus the quantity x to the third minus 4x equals 0, comma x. When you solve this, you do get 0 and 2. Because that is where it intersects. So if you want to find the area of R, it'd be equal to the integral from 0 to 2 sine pi x minus x to the third minus 4x times the differential dx. And when you do this, you actually get 4, which is a nice number. Okay, part B. Well, this one you can do by hand technically. Part B says the horizontal line y equals negative 2 splits the region into two parts, right? But do not evaluate an integral expression for the area of part R that is below the horizontal line. So it says you have this line and it wants you to find this area over here. But now if you notice, your boundaries just switched. So we're going to have to use our calculator again to solve. Top minus bottom, set it to 0, so negative 2 minus. The bottom function is x to the third minus 4x. Set it to 0, comma x. And when I did this, I got a couple points, but the ones that should be of interest to us are the ones in the first quadrant and the fourth quadrant. We don't want anything that's not there, so you could also graph it and see where it intersects. That might be better, because then you're safe. At least you're not picking some of the wrong points. So 0.539, about approximately. And then the other one is approximately 1.65, 675. Okay, so now when we want to find the area of this, the way that we would do this is we would say the area of the part of R below y equals negative 2 is equal to, you would now use your new boundaries, 0.539, 1.675. Now it said do not solve, so all we have to do is write it, which is good. So negative 2 minus x to the third minus 4x dx. Okay, part C says the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Find the volume of this solid. So the good thing is we already have this function here. And we know it's going to make a square. So we're going to say the volume and this is part C, would equal from 0 to 2. And now you just make it into squares, so you need how big the side is. So the side would be whatever this distance is here. So I know this is kind of hard to see. So let me see if I could use a different color so you could see it. Green will work. So you would do this, however big that is. So that part is can be the function that I underlined before, sine pi x minus x to the third minus 4x. But you need to square it because it's side squared times all differentials, all the little thickness, and that's how you're going to get your height. And you should get approximately 9.978. Okay, part D. The region R models the surface of a small pond. At all points in R at distance x from the y-axis, the depth of the water by h of x is equal to 3 minus x. Okay, so part D, volume, would be the formula we had in part A, but you would do 0 to 2. Now your height is 3 minus x times whatever you had in part A, so the sine pi x minus x to the third minus 4x times dx still, and you should get roughly about 8.370. And I hope this video helped.